Here we have problem 24.19 with 3 point charges and 3 surfaces with 2 point charges in each one. And we're also given the amount of flux going through each surface. And we also know that the point charges are on the same plane as the surfaces, meaning they're not like above or below the surface. So from that, we can solve for the amount of flux going through we can solve for the value of the point charges going through each surface. And the way to do that would be to first, we have the equation to solve for flux, which is the electric field vectors times the area vector times the cosine of the angle between the area and the electric field vectors. And so the area of the point charge is basically the surface area of the charge, and that we know that the point charge is a sphere, and the surface area for a sphere is 4 pi r squared. So that we can use as the value for A. And we also know that since the point charge is on the same plane as the surface, theta is going to be 0. And so the cosine of 0 is just 1, so we can just ignore that. We also, the value of E in this equation, we know the equation for E is equal to kq over r squared, and we can rewrite that as k is equal to 1 over 4 pi up E0, and so we can just combine all of that into the equation to write it as q over 4 pi r squared E0 is equal to E. So then, rewriting the whole equation, we get q 4 pi r squared over 4 pi r squared E0, and those just cancel out, so we're left with the flux going through the surface is equal to q, or the charge, over E0. And since we're also given the value of each of the flux going through each surface, we can determine how much of that is from each point. So we know that for surface A, which is the orange one, the amount of flux is negative q E0, and that total flux is going to be equal to the electric field vectors and the area vectors multiplied from q1 and q3. And so we can really just add those two up. So it'd be q1 over E0 when we solve for the amount of flux from that 1 point charge, and then we just get the amount of flux is equal to q1 plus q3, because they're all going to be over E0, so we can just ignore that for now. And so we do that for every single surface. So surface B, which is the red, would be q1 plus q2, and the third surface, or surface C, is just q3 plus q2, and it's all written down here. And so this is basically just like solving a system of equations. So what I did here was I took one variable, which was q3, and I found the value of that, and then I just substitute that into this other equation. So q3 is equal to negative q minus q1, and so I just plug that into this equation. So I get 2q is equal to q2 plus negative q minus q1, and then you can rewrite that to find the value of q2, and then we also know there's another value of q2, which is this one, which is just 3q minus q1. And since those two are equal, we can just do the math to solve for the value of q1, because that's the only variable left when we put these two equal to each other. And then we find that q1 is equal to 2q, and then we can just solve or plug in the value of q1 into every other equation. So if that's q1, then we can solve for q3 by plugging it in. So we got 2q is equal to q1, and then solving that gives us negative 3q is equal to q3, and then solving for q2, we have just plugging in 2q as q1, so we get 2q plus q2 is equal to 3q, and then solving for q is equal to q2. So basically, the value or the magnitude of the charge is each charge is equal to 2q, negative 3q, and q. And an assessment for this could be like looking at the amount of flux going through each one. We see that C and A both have negative fluxes going through them, and the only value they share in common is q3, meaning that has to be negative, and we found that it was negative. And then we also know that B has to be positive because it's 3q, and so q1 and q2 both have to be positive, and that's true here, where q2 is just q and q1 is 2q. So then you can also find like the values of each q, or like specifically in relation to each other, like q1 and q2. So here q3 plus q1 would be like a negative plus some value, like it's negative 2, and same out for this one. So q1's probably going to have to be bigger than q2, and that's true because q1 is 2q and q2 is just 1q, and that's the answer.